So question number 5 says which alkane, when any one hydrogen atom is substituted by a chlorine atom, will not produce an isomer. So what is asking is that all of these are alkanes, and it says that, let's say if I remove one hydrogen from there and add a chlorine, which of these will not produce an isomer? Now isomer, again, the definition is same molecular formula but different structural formula. So let's look at this one for example. Now here, let's say in place of this, let's say in place of this chlorine, if I this place of this hydrogen I place this chlorine, and what does that become? So that becomes CH3. So the first here is that you have CH3 and a CH3, but once I place a chlorine here, it's going to become CH3 and CH2 Cl. Let's say I place this chlorine here. What's the formula going to look like? Again the same, CH3, CH3, CH2 and a Cl. So basically the answer for this is actually part A in itself, because why? No matter wherever I put the chlorine molecule, even if it is here, even if it is here, there is going to be no isomer. The thing remains the same. So this is your answer. Okay, let's look at question number 6. Question number 6 says the diagram shows two compounds. Okay, it can be predicted from their formula that the compounds have the same what? Okay, so looking at their formulas, we need to figure out what is going to be the same. So here you have C4, 1 2 3 4 5 6 7 8 9 10, it's 10, and here you have again C4 and 1 2 3 4 5 6 7 8 9 10. So basically this is a branched isomer. What can we deduce from this? It can be predicted from their formula that the compounds have the same boiling point. Now you need to remember, once you go from once the carbon chain changes, because here you see if you have a straight chain and here you have a branch chain. Okay, once the chain changes, the boiling point and the melting points are gonna change. Okay, because the molecule is now different. Okay, so this cannot be correct. Composition by mass. Now composition by mass means that if I were to write a C4H10, composition by mass means how many what percentage of carbon is there and what percentage of hydrogen is there. So if I look both of these figures, both of these figures are C4H10. So this one is C4H10, the first one. The second one is also C4H10. So basically when I figure out the composition by mass, it's gonna be the same for both. Why? Because both of them in both of these scenarios are in the same ratio. That's why this is also going to be the answer. Now why not melting point? Again the same idea, because once the branch has been introduced, the melting point and the boiling points are gonna change. Structural formula. Now here you can say, just by seeing the picture you can clearly see that the structures are different. Here you have a straight chain, here you have a branch chain. This is what change in structure means. So this is also not correct. Okay, let's move to the next question. Which statement concerning isomers is true? Diamond and graphite are isomers of each other. That is, let's see about this. Part B. Isomers have the same general formula. Isomers have the general formula CnH2n plus 2. Now we cannot be sure about that, because maybe that is about alkenes. We don't know that. Okay, let's see this one. Isomers have the same molecular formula. Isomers don't have the same molecular formula. It actually has a different molecular formula. Oh sorry, yes, it has the same molecular formula. I just got that wrong. So this is your answer. It has the same molecular formula but different structural formula. That's the thing. So that's your answer. I didn't even need to look at these things. Why? Because they were not entirely relevant. If you study the O-level syllabus, hardly you will see somewhere where it is written that diamond and graphite are isomers of each other. You don't even study diamond and graphite in the organic chemistry. So I did not even had to look purely or go into the concepts of why the above MCQs were wrong. Okay, so that's the idea. Let's look at this question. Compounds X and Y are both alkanes. Okay, now both of these are what? Alkanes. Compound X has a higher boiling point than compound Y. So the compound X is going to have a higher boiling point than compound Y. So basically what means is that in the series, compound Y is going to be here and compound X is going to be here. Why? Because X has a higher boiling point. What could be the formula for compound X and Y? Okay, what could be the formula? Now one thing is for pretty sure is that the number of carbon and hydrogens in the compound X needs to be greater for the higher boiling point to be more, for the higher boiling point, of course. Compound Y is not going to be greater. Let's see this. Let's see the first part. C8H16 and C9H18. This is the opposite, which means compound X has less molecules than compound Y. You can see that. Here you have 8 carbons, here you have 9 carbons. Here you have 16 hydrogens, here you have 18 hydrogens. But this is not right. Why? Because we need a structure where the carbon and hydrogens for compound X is more and compound Y is less. Why? Because X has a higher boiling point. So X needs to be second or third in the series, not at the start. Okay. So this is why this is wrong. Let's see this one. C8H18 and C9H20. Again, the same thing. This is also wrong. Why? Because compound X is smaller than compound Y. That cannot happen. Let's see part C. Part C is C9H18 and C8H16. Yeah, that can be true. But let's just figure out. This is C9H18, which is, it says it is X, and C8H16. Now, by theory, it is right. But what we need to actually see is that are these actually alkane molecules? Because here these might be alkene molecules, we don't know, so we have to double check if these are alkene molecules or not. So what we'll do, we'll put them into the formula CnH2n plus 2, and here you have number of carbons at 9, so C9H2 9 plus 2, C9, this is 18, and 18 plus 2 is 20, so this is correct. Let's see this one. So you've got C8H2 plus 2, that's C8. This is 2 plus 16. 16 plus 2 is 18. See, by formula there should have been 18 hydrogens. How many are there? There are 16. So this is also wrong. So by default, this is the correct answer. Okay. All right.